Okay, this is part 2. We only have 3 pages left of notes to do, so we're almost done. Um, in the last part, we did more expanding, and now we're going to practice some condensing. So our goal is to condense to a single logarithm, so you should only have log written one time. If you look at all of these, natural log is written more than once. Here, natural log is written more than once. So we want to condense it down to just one logarithm. So we're going to use all the properties, but now backwards. So for example, in part A, I have a 2 in front here. I could take that 2 and write it up as an exponent. So I could say that this is natural log of x plus 1 squared minus natural log of x. And if I condense that into just one natural log, subtraction turns back into division. So I would have x plus 1 squared divided by x. Now it's just condensed down into one natural log. Let's do C. I could take the 2 down in front and bring it up as an exponent. I could do the same thing with the 5, bring it up as an exponent. So then I would have natural log of 8 squared plus natural log of x to the 5th. And addition condenses back down into multiplication. So I'd have natural log just written one time, and then I would have an 8 squared times an x to the 5th, which I can then just write as natural log of 64 x to the 5th. And then in part D, same sort of thing, bring all these numbers up as exponents. So we'll have natural log of x to the 3rd plus natural log of y squared minus natural log of z to the 4th. And then just remember, addition condenses into multiplication, subtraction condenses into division. And I'm only going to have natural log written once. So then I have a x to the 3rd times a y squared divided by z to the 4th. For part B, all you really could do is just bring the 3 up. You just have log base 4 of x minus 9 to the 3rd. That's all there is you can do. Okay, we're going to practice these without a calculator. So again, if it seems like it's impossible to do without a calculator, you can, you're just forgetting the properties that make it easier. So again, like 49 to the 3rd, I don't expect you to know what that is without a calculator. So I do want you to use your property that says bring that down in front. So you'd have 3 times log base 7 of 49. You can do log base 7 of 49. Seven to what power equals 49? So that's a 2. So we have a 3 times a 2, and then you get 6. That's totally doable without a calculator. This is a good one, number 2. I can bring the 2 down in front, and I would have a 2 times 4 natural log of e, or I could say 8 times natural log of e. Well, if you know your other properties, you'd be able to tell what natural log of e is pretty easily. But let's say you don't have those ones memorized. You can write this as log base e of e. E to what power equals e? That's a 1. So natural log of e is 1. So we've got 8 times 1, and we get an 8. Let's skip over here to number 4. We can bring the 6 down in front, and we can bring the 5 down in front. So we would have 6 natural log of e minus, multiply the 5 times 2, 10 natural log of e. And over here, we already did natural log of e in the other problem. Natural log of e is 1. So I have 6 times 1 minus 10 times 1. 6 minus 10, get a negative 4. Number 3, this is a cube root. Anytime you see roots, I think it's helpful if you write them as an exponent. So this would be log base 6 of 6 to the 1/3, because a cube root is the same thing as a 1/3 power. I can take the 1/3, bring it down in front. So I'd have 1/3 log base 6 of 6. And then what is log base 6 of 6? 6 to what power equals 6? That's a 1. So we have 1/3 times 1. We get 1/3. So knowing your properties makes it go a whole lot better. This is the last thing. It's called change of base formula. It used to be really important before we got the new calculators. On the older TI calculators like TI 84, TI 83, they couldn't do log base 6. They could only do log base 10, which was just log, or they could do log base e, which was natural log. But if you tried to do any other bases on one of those calculators, it didn't give you, like when you typed in log, it didn't give you a little box for the base. That just wasn't there. So in order to do a problem like this, log base 6 of 241, you had to use this change of base formula in your calculator. So here's what it says. We're literally going to change the base. So currently the base is a. We can change the base to base 10. It's not written, but it's a base 10. We could change the base to a base e. Natural log is base e. We could change the base to some other base. But what you do is you take this x value that goes on the top, and the previous base, the original base number, goes on the bottom. So you can do any of these. You don't do all 3 of them. You just pick one. So for example, this log base 6 of 241. I know you can type that in your calculator as is with the new TI Inspires. But on the old calculator, you would have to type log 241 divided by log 6. You could type that, or you could do natural log. You could do natural log 241 divided by natural log 6. You're going to get the same thing. All of these are equal. When you type that in your calculator, you get 3.06. Well, okay, so like I said, you can type that straight into your calculator because it gives you the little base box to put the 6 in, and it gives you this box to put the 241 in. Well, what if you get to a problem like this, where you can't really use your calculator because I didn't tell you what base A was? So, if you know your change of base formula, this problem is doable, even though you can't really do it in your calculator. So, it doesn't matter if it's a B or if it's an A or if it's an X. It doesn't matter what the letter is. I'm changing the base. So try to compare this to this. So you see how whatever is on the top is this X value, and whatever's on the bottom was the base. So I can rewrite this kind of going backwards. I can say log base 8, because see how the base A is here? And then whatever's on the top, that goes in this spot. So it'd be log base 8. And then natural log of E. What is natural log of E? Go back a few pages. Natural log of E was 1. Remember that? So this is really a 1. So it's really like I have log base A of 1 over log base A of 8. So the 8 is the base here, and the 1 would go here. I know that looks strange, but just kind of go backwards. See how what's on the bottom is the base? So what's on the bottom is the base. And what's on the top goes here. So 1 is on the top, goes here. Now you can do that without a calculator. Log base 8 of 1, what does that equal? 8 to what power would equal 1? Oh, is 0. So this whole thing equals 0. Ha ha ha. And that is it for our notes. So now go ahead and start working on the homework, and I will see you tomorrow. Okay, bye.